Well, how are you doing? Okay, the title of this video is that sunsets do not exist. Okay, I'm going to go through how sunsets don't exist even on the heliocentric model. People have been under the impression that the heliocentric model claims that a physical sun goes down behind the physical horizon um, for a long, long time, and that is actually not the case. At no point within their model is there a physical sun going down behind a physical horizon. So when someone asks someone on our side of the argument, the flat earth side, how do you explain a sunset, right? It's nonsense because we explain it the same way as ye explain it, which is the meeting of two optical phenomenons. An apparent optical horizon, which is just an optical phenomenon, meeting what's known as the sun mirage. It's just meeting another optical phenomenon. So it's two optical phenomenons meeting. That's all it is. And that's exactly the same claim within the globe model officially. But people have it in their head that it's different. See, what people don't realize is that I'll take Neil deGrasse Tyson as an example just before I move on. Neil deGrasse Tyson went to the Burj Dubai, which is the tallest building in the world at present in Dubai. And he watched a sunset, what he thought was a physical sun. Well, he knows it's not, I'm sure, but he alluded to it being a physical sun going down behind a physical horizon across the desert. This is what he said he watched from the base of the Burj Dubai. Then he claimed to go into the Burj Dubai, go up to the top floor or whatever, and watch a second sunset, right? Because he had rose in altitude and elevation, so it allowed him supposedly to see the sun come back up, right? A physical sun come back up from behind the physical horizon. That was blocked for him at the base to see the sun set a second time, right? This is what he alluded to. This is the impression he gave. Now, what Neil deGrasse Tyson didn't say was that this doesn't happen with the stars and the celestials. This doesn't happen. Once they are gone out of visual view or optical view, they don't come back up. You can raise an altitude and they don't come back up. Why don't they come back up? Because the sun is never going down. They don't go down. They all just go away, right? How they work, what they do, how they do it, what they're composed of, I have no idea, right? But I know what they're not doing, and they're not going down. They're not physical objects that are going down behind the physical horizon. The reason that the sun can appear to set is because the sun, at least for from our position, is much bigger, right? Let's just say optically to us it appears much bigger, but also the sun creates temperature and movements in temperature and changes in temperature, right, as it moves, whatever it is, as it moves around our sky. So this, especially with perspective, as it gets to about 10 degrees, it's going to start causing, and it does start causing, all kinds of weird things at the horizon, right? This is what the sun does. Now, we don't see that with the stars. What we see with the stars is they appear to slow down as they get close to the horizon, and then they kind of just peter off away. They try and explain this with what they call a celestial refraction. Now, I'm not sold on celestial refraction. I think it's more of a perspective issue, where they're starting to go into your horizontal as opposed to their rate of apparent drop, right, from your 90 for a star to your horizon. Let's say you're looking at over the ocean, the rate of apparent drop changes. So they have to, because they need to keep it somewhat mathematically constant. They add in celestial refraction, right? But celestial refraction may be correct, but I get the feeling it's not. I think it's more of a perspective issue, where the stars, as opposed to continually going down, they start to slow down because they're starting to go into your horizontal. And when something goes into your horizontal, it's literally like a straight line from you, and it takes a while for it to disappear. And eventually, the stars, if you watch them, they don't go behind anything. They just get to a point of disappearance, and that's it. That's what they do. And if you can see stars do that from your, like optically, you're watching the stars appear to do this at the horizon from the base of the Burj de Bois, and you know what stars that you've seen do it, right? Notable ones. And you then go up to the top of the Burj de Bois, you won't see those stars back up over what you think is over the horizon. You won't see that. It only happens with the sun, moon maybe as well, but it doesn't happen. I don't know about the moon, but it does happen with the sun. Now, I'd say it probably does happen with the moon because the moon is equal in size from our perspective. So we're seeing something is about zero point 0.5 degrees for both the sun and the moon. So it, so I do, but then again, I don't know. I'm not going to bring the moon into it because I haven't looked into the moon and what happens with moon rises and moon sets. People have said they haven't seen the moon rise and set like the sun, which would make sense because the moon is not creating heat like the sun is creating. The sun is creating heat and radiation, causing issues like that. So it appears from our perspective, from our position, that this physical, like it's described to us as a physical sun going down behind the physical horizon, when that's not the case, even within the official heliocentric model. That's not the case. So that doesn't happen. We're just told it happens. It doesn't happen with the moon because the moon is not creating heat. So we're not going to see the same effects with the moon as we will see with the sun. But this is just mainly working on the sun and the fact that the stars don't behave like the sun. Only the sun behaves like the sun. The moon doesn't behave like the sun, although it's close to it or similar in its behavior. It doesn't still behave like the sun when it comes to the horizon. Because what is the horizon? It's the apparent meeting point of the land, water, and the sky. The apparent meeting point. So that's what we observe. We observe this apparent position. It's an optical position. And what they call a sunset? It's the sun appearing to meet that. And it's given to us as we grew up in my age, or in my generation and the generations prior and after me, that the sun is this physical object and that we're rotating away from the sun, and that causes the sun to go behind the physical horizon. But this is the problem. Now I know better, and all my observations as a young kid, being out on the water when I didn't even want to be, in fishing boats and stuff like that, I got to see all these different sun set type things happening. I got to see all this stuff happening, and I didn't see not one time, that I see something that looks physical going down behind something else that looks physical. I didn't see that. I saw the meeting of two optical phenomena. That's what I saw, and that's what everyone else sees. Nobody sees what we're told is supposedly happening. Nobody has ever seen that. They will never see it. It can't be seen because it's not happening, right? So let's move on, right? Here we have, right? I just opened up Metabunk here, right? Because Metabunk is the all-round best of them, I think. Distance in miles 4, viewer height in feet 6, right? This is the globe, right? Here we have refracted horizon, right? So this is the refracted horizon. With the refraction approximation given an effective radius of 4,618.83 miles. So that's the effective radius of 4,618.83 miles, right? So this means is 7/6R. What it means is that on a globe, right, if we are the globe plane, is that we are always viewing a globe Earth that is no smaller than a globe of a radius of 4,618 miles. That is the limit. We never get to see any globe or observe anything that would be even smaller than that. We are always told that we're observing a world that's actually at least that and bigger, so greater than 7/6R, as this is just, as they call it, standard refraction or terrestrial refraction, because it's not actually refraction. It's a mathematical change in the radius, what they're calling an effective radius of a globe Earth. And what it actually does is it turns the globe Earth from being a circle into an arc length, right? That's what it does. It turns it into an arc length. And it makes up other parts in between with basically a ghost, right? A ghost. That's what it is. That's what I could call it. A ghost arc length or a ghost circle. That's all it is. It's making up the part in between. But the point is that the globe Earth, the official claim is that we never observe an actual physical globe. We observe, right, a refracted globe at all times that refracts at unknown amounts from day to day, right? This is how it's explained to us. So standard is just, the standard is 7/6. So that means there will never be less than 7/6. You will always observe at least 7/6 and greater than 7/6 or, right, which is the change in the effective radius. Because this is their real effective radius is this. There is no geometric radius, can ever be measured because there's no geometry that can ever be seen due to their horizon always being refracted. Because they have to admit that the horizon is not a physical location, because the horizon does things that they can't describe and account for on a geometric globe of 3959 miles. So they have to add in an effective radius, right? Refracted horizon. This is what they're saying. So the geometric horizon is 3 miles for a distance of 4 miles away and viewer height of 6 feet. But the refracted horizon is 3.24. That's an extra 2.24 miles, right? So it's 15,838 feet as opposed to 17,107 feet, right? So it's an admittance from their side that there is no such thing as a globe's geometric horizon. The horizon is an optical phenomenon. That is, no matter what way they want to explain it, it's an optical phenomenon. It's not geometric. So anything that appears to be meeting the horizon, whether it be the sun or anything else, they're not meeting a physical location. That's the point, right? I just want to come down here. It says, note, not accurate for observations over water very close to the horizon. Now, 6 foot high would be what Mick West would term as very close to the horizon. Now, they add in, unless the temperature and vertical temperature gradient are accurate. But that's a mathematical thing, right? That's what that is, where they have to mathematically talk about the index of refraction, all this nonsense. What is refraction? It's a change in media. Light moving through a change in media. What is actually refraction? It's like going from one medium to another, 2 different mediums. That's what refraction really is, right? But that's all that is, unless the temperature and vertical temperature gradient are accurate. That's all based around what they call the index of refraction, which is just basically a mathematical way of trying to make up for what the globe can't do, right? Basically, right? It's nonsense, right? But it doesn't matter because the point is it's not accurate for observations over water very close to the horizon. Why is it not, right? Because this turned up after the black swan, right? So let's look for a moment, right? Here we have this green circle. This is the 3959, right, radius globe, right? This red circle is the 4618, right, radius, effective radius, refracted 7/6 globe. So this red circle is what we're told we will always at least see, and we will see, right, that at least and greater, right? We will never see this green circle, right, because that's the geometric globe that cannot be seen at any point, right? Because it can't be seen, so it can't be geometric. It can only be mathematical, right? Because you can't measure something you can't see. It's nonsense, but this is what they say, right? Now, when it comes to this photograph, right, and there's been photographs taken, video taken by this man, BLMSB69, that have shown horizons way further than is shown in this, from the same viewer height of 1 foot. Here you can see the horizon's at least 10 miles away. We'll give it an arbitrary 10 miles, but it's possibly a lot further because it's in your horizontal view almost. So it's hard to see how far away the horizon is because it's almost in your horizontal view. So how do you determine how far away it is? When something, just like with the stars, when they start going into your horizontal view, how do you determine how far away they are? How to determine that? Because eventually they will keep on going to the point where they'll appear slightly lower in your horizontal view due to optical drop, and then eventually they'll just disappear, and that's that. They won't go down behind anything. That doesn't happen, right? But you're given the impression that that's what happened, right? this is just the way it is, right? They give you the impression of these things. A lot of people who research sunsets a lot, as I will show in a few minutes, they all have the impression that the horizon is a physical location. Most people in the world don't realize that it's not a physical location officially. But just for instance, for this, right, from a 1 foot observation seen 10 miles away, right, what the globe has to become, right, for that to be explained on the globe. Now, this is foregoing any curvature between the observer and the horizon, right, foregoing all that. What the globe must explain, how the globe must explain this is by creating a much, much bigger globe. So the globe becomes only a tiny arc length. And I show you, right? So watch as I go out. Here we go. That is the size the globe Earth must become. That's the size the globe Earth must become to with an effective radius of the correct one is 263,000 miles. That is the correct radius that globe would need to effective radius that the globe would needs to claim to explain that photograph. But you end up with, right, let's say there's the little globe green in the middle, right, and the red around it is the 7/6 globe, right. Here is the 263,000 mile radius globe. I think it's like 148/6 or something great. I can't remember what it is. Adam told me. You all know who Adam is. But this is what the globe becomes. It becomes an arc length. That's what the globe becomes. So the globe becomes this little arc length here, right? So that's what the globe becomes. So for the black swan photograph to be explained, they had to make the globe this little arc length here. That's what they had to make it, and the rest of this is just kind of a ghost arc length that they had to add in. So that's how ridiculous it is. This is what they must do. And as I said, there is greater observations made by the same person, BLMSB 69, since that black swan photograph. That's just an arbitrary photograph we just used as an example, right? So that's how ridiculous it is. So at no point is the horizon physical, even within the globe, even within heliocentrism, the horizon is never physical, right? So let's move on. So sunset mirages. Now these happen at sunrise and sunset, right? But they mainly just talk about the sunset. So sunset mirages. 2 or more images of the sun are seen when its low slanting rays are unusually refracted between air layers of different temperature. Usually the air temperature falls smoothly with increasing height. The most we then see is a slightly flattened sun. A mirage needs more severe temperature variations. One class of mirages, M-mirror sunsets, occur when there is a temperature inversion. Warm air overlays colder layers. The sunset mirage at left was produced by multiple inversions. Another sunset mirage from Jules Verne called it an Etruscan vase. I don't know what it must be. It must be Latin or something. I don't know the words. Occurs when the sun-warmed afternoon sea produces an abnormally hot air layer close above its surface. Miraged suns often presage the elusive green flash. Now, the person who wrote this, right, they are, you have to remember, they are pre-assuming that the horizon is a physical location. They're not a flat earth or anything like that. They don't know that the horizon is even within their own model, not a physical location, and it can move about. And within their own model, they don't know that the horizon they're seeing is officially not physical. They're under the impression that that's a physical location that boats can sail over. Physical boats don't sail over refracted horizons no more than optical suns go down behind refracted horizons. The whole point is that none of them are physical. So a boat can't sail over something that can't sail over refraction. It's impossible. Boats sail on water, which is part of geometry, or which is part of a geometric earth, I should say. Boats don't sail over refracted horizons. And more to the point, something else I will make a video on, is that boats that we see, besides the explanation for how they do what they do at the distance, what we see is a boat disappearing uniformly. I did make a video about this in the past, but I'll make another one that's going to be a bit more hard hitting. Boats disappear uniformly from the base up. Right now, it's diffraction. Now, there's different things going on out at the horizon because it is all kinds of temperature stuff going on, and like there's all different effects happening out there. But from just a purely optical point of view, just to do with your eyesight, it is diffraction due to the angle, and that's why there is a uniform disappearance from the bottom up. That's why it can be seen that way. Now, it can be seen in different ways because you have inferior mirage, which can be out at the horizon, and you can't see that it's an inferior mirage, so you don't know what's happening. It just appears to you that the boat has disappeared bottom up. But really, if you could zoom to it, it's actually just inferior mirage. That's what it is. So often the time people thought inferior mirage, when they see a boat being inferior miraged in the distance, they thought that it was going over a curve. It wasn't. It was just being inferior miraged. But the point is that a boat disappearing uniformly from the bottom up has absolutely nothing to do with a curve or curvature or the curvature of a spherical Earth. Nothing to do with it. If a boat was sailing over a curve, then it has to be bow down and stern up. Right? That means the bow, which is the front of the boat, must be down with the stern, the back of the boat, up. So you're not going to see a uniform disappearance from the bottom up. You will not see that. You will see, what you will see is, the last thing you'll see is the tip of a sail, let's just say, and the back of the boat. That's what the last thing you'll see. You won't just see the top of a sail or the pole of a sail or something like that. You won't just see that. You will have to see the back of the boat with the tip of the sail around the center of it. If it's off in a direct horizontal line from you, going what you think to be over a curve. If that was what was happening, the last thing you would see was the back of the boat and a tip of the sail at the center. That's what you would see if it's going over a curve. What happens when you see a car drive over a hill? You don't see it disappear uniformly in layers from the base of the tires up. You don't see that because it's going over a hill. You don't see it, but you do see that with boats from time to time at the horizon. Why do you see that? Because it's an optical phenomenon. That's why. There's nothing to do with curvature. There is no curvature. So it's just the horizon is just being hijacked. That's really what's going on. But anyway, the people who wrote this were under the impression, even though they're talking about the sun mirage, they were under the impression that the horizon was still a physical location. It's not. So we'll move on. Right. Sorry, that's something else. I don't need to go into that. Right. Not into that either, I don't think. Let's see. Right. Here is the sun mirage. Right. When you're in the evening time, you think you're seeing the sun, and the same happens in the morning. You think you're seeing the sun, right? What's happening is you're seeing what the sun has left behind. From your location, you're actually seeing a mirage. That sun is not sitting there. That's why the sun is often looks equal in size when it was at midday, or a size even bigger in the evening sometimes than it was at midday, because in the evening time it's after due to it being affected by air and heat and different things. It can expand. It can appear to expand, right? So sometimes it appears even bigger at sunset than it is, especially in more damp areas or more humid areas than it is at midday, right? Because you're seeing it in your horizontal view as well. It's after appearing to get to your horizontal view and it's moving away. But what you're seeing here is the mirage, the sun mirage. That's what that is. As you can see, this is inferior mirage here, and you can see how the sun appearing to melt into it. Now, if you're at a great distance from this, according to you, it appears like the sun is going down behind something, but it's not. That's not the physical sun, and that's not a physical horizon. None of this is physical. It's all optical. So next one, same again, not physical, just optical, right? That's all that's going on there. It's purely the meeting of two optical phenomena. Once again, the meeting of two optical phenomena. That's just the sun on its way out across the water. It's a little bit oblong. But I just wanted to put that in there just so people would have something to mentally grasp as to what that will become something like this, basically, right? Here we are again. That is more like if you look at this last one, is probably going to become something like that. You know what I mean? There you go. Where you're under, this is an inferior mirage, where you're under the impression that that it's at a distance that the sun is going down behind something. It's not. It's just moving away from you, and you're left viewing this type of an effect, right? Same here. It's just like the sun mushrooming or whatever. Here we are again. This ridiculous kind of a mushroom effect. It's like looks like a mushroom explosion. It's all optical. This is the sun over the Arctic Circle in the summer. So that won't set at all. Won't appear to set at all. It'll just kind of move around. Just had to throw that in there because it was a nice photo. Here we are, more the same. Look, optical phenomena meeting another optical phenomena. So the meeting of two optical phenomenons. Here we get into the globe explanation, right? As you can see, this is the horizon, a straight line, but yet they have them standing on the globe. And they always have to put this tangent plane on top of a globe. They always have to do it. And they say the true position is below this horizontal, but we perceive it here. No, this is pure hijacking of reality. They have no evidence of this true position down here. What we have here is this sun here that the person sees, right, and it starts to melt into the horizon, which is also not an op. So this is the horizon here. This is not a physical location. This is an optical location. But this sun here has continued on in its path that way, away from the person, and the person ends up seeing a mirage of the sun meeting water. And to them, it appears like the sun is going down behind, but it's not. There's no evidence of any of this nonsense where the sun is going down behind anything. It can't go down behind an optical phenomenon. Even if the sun was like the sun, whatever the sun is, whether it's physical or optical, or I don't know what the sun is, its composition or what it is, how it does what it does, but whatever it is, it can't go down behind an optical phenomenon. The optical phenomenon can block it, can give the impression that it's been blocked at the bottom, whatever, but it can't go down behind it because it's just an optical phenomenon. This is the ocean, and it continues on out past that way. So this line here that the observer is seeing, what they are seeing is the mirage here, but that sun continues on. It continues on in its path. It goes off out to the left. It continues on in its path. Same thing here, where they're showing this oblong sun here, and they're saying that's the true position of it, and they're calling this the atmosphere. But really, all this is here you have the horizontal plane of the Earth, and this is just the celestial dome. That's all it is. Where someone watched, if someone was here, they watched the sun above them here, and gradually, due to perspective, appear to end up in their horizontal view. That's all that's happening there. Same again, they're at the same stuff again, apparent position of the sun. And the true position is down here. What the true position is at a place that nobody can see and nobody can prove. No, the true position is off out, way out in this way, off out to the left of the screen here, not down here. Right? And what you're seeing is what you were told was a physical sun going down behind a physical horizon. That's what they told you. But that's not true, is it? Even within their own model, they have an apparent sun and a refracted horizon, even within their own model. Absolute liars, incredible liars. But that even a lot of their own people didn't realise that, and some of them still don't. But that's the point. They can never ask us again, and have no business asking us how do you explain a sunset. We explain it the same as ye. Two optical phenomenons meeting. We explain it exactly the same as ye explain it. Exactly the same. With the exception of we don't think some physical sun is going down behind some physical horizon. You know, as in the aftermath. We're not saying that. But as far as how does the optical thing happen? It happens because it's two optical things meeting. That's how it happens. Same way as ye. Same way, exactly the same way as ye claim. Exactly the same way. Same again, look, actual position, apparent perceived position, and they have this straight line. It's always the same rubbish, right? Sorry, this is, it doesn't matter. So same thing again, right? Observer, straight line. Oh, and this has gone below the straight line, has it? Where's the evidence for any of that? Absolutely zero evidence, especially because this straight line is within their own model, a refracted horizon. Nonsense. Same on nonsense again, straight line, true position, apparent position. No, its apparent position might be it might always just have an apparent position. How about that? When it's at your 90, right above you, that's its apparent position, right? You don't really know what position it's in, how high up it is, or well, it's at and after 90, it's definitely in an apparent position. When it's at 48 degrees, it's at an apparent position. It's always at an apparent position because from your perspective. And here we have advanced sunrise and delayed sunset. Now, this is the thing, you see. This is the mirage in the morning and in the evening time. Same thing. It's sun mirage. That's what it is. So you can never determine where the sun really is. Really, when it's at your 90, you can say, okay, it's kind of at my 90, right above you. You can say that. But even at that, you don't know what it is, how it does what it does, how high it is, how big it is. You don't know any of them things. You can make up a story like they do in heliocentrism, but who needs stories? We need facts, or we need honesty. And facts are, it does this is the proof of it, or honesty is, we have no idea. That's the honesty. And that's what I'd say. We have no idea, because we don't. More of the same, mushrooming, double sun type stuff. Here we are again, as the sun sets, blah, blah, blah. More of the same. Optical phenomenon. Sunset science, the mock mirage. Now, take into account, again, that these people are pre-assuming that the horizon is a physical location. So you must take that into account. They don't know any different. This is 1997 Optical Society of America. But it doesn't matter if it was made today, these people still wouldn't know different. Abstract. A previously unrecognized phenomenon, which we call the mock mirage, produces inverted images of the sun and moon near the horizon when the observer looks downward through a thermal inversion. No ducting is involved. The rays can be concave towards the Earth throughout their length, with a radius of curvature larger than the radius of the Earth, about the globe. As I said, they think it's a physical horizon. Quite mild inversions produce surprisingly large effects, which increase with the height of the observer. Although the phenomenon has frequently been photographed, published pictures have been misrepresented. Finally, we distinguish between features that are due to waves on inversion layers and the larger features that are due to the inversions themselves. Right? So what they're talking about here is, what they're basically saying is, this weird thing happens and we don't know what it is, because we should have a physical sun going down behind a physical horizon, but that's not what we see. That's the translation of that. We're making stuff up to try and explain away something that makes no sense within our worldview. That's basically what's going on. So here is more the optical phenomenon that you would see. This is, inferior mirage. It could be superior. I'm not sure if it's superior or inferior. Yeah, because I think it's superior actually, because it's going up the way. So it's superior mirage, but there's just like more, and there's a horizon behind it. You know what I mean? It is all bizarre. Out at the horizon, we don't know what it is. It's just this optical position where anything goes, kind of thing. Same kind of stuff again. That's more the superior mirage there. So superior and superior mirage type stuff going on there. Here we have the phenomena of the floating boat, which is just reflection off of the sky onto the water, causing the effect of the boat floating when it's actually still on the water. It's not floating at all in the air. It's floating on the water. And here, same again, floating on the water, but it gives the effect that this is air and not water due to the reflection from the sky or whatever onto the water. Now, this has all been shown before, but I just wanted to throw it out there just to show how optical this all is. Same again, another one again. Boat supposedly floating in midair when it's not. Right? It's just an optical effect on the water. So the Omega Sun in Japan, mysterious and lucky winter phenomenon. So if you are staying in a coastal area in Japan, sometimes between late autumn and early spring, you may have a chance to see this omega-shaped sun at sunrise or sunset. It will definitely be a memorable experience. It's getting colder, making it harder and harder to get out of bed in the morning, but an early bird catches the worm. If you get up and go to the seashore to see the sunrise, you might be rewarded with this gorgeous, mysterious scene if you're lucky. The photograph doesn't show up there forever. Well, why does this happen? The phenomenon is called omega sun because the shape looks like the Greek letter omega. It is a mirage caused by the temperature difference in the air and the refraction of the light. In cold season, with the seawater is much in cold season, when the seawater is much warmer than the air, the lowermost air layer is warmed up by the water and produces a temperature difference, right? Um, the omega shape is a type of inferior mirage, blah, blah, blah. The sun produces above the horizon at sunsets, at sunrise. It's inferior mirage, blah, blah, blah. It goes on. I just won't go into too much about it. You can research yourself. But basically, they're talking about sunrise, sunsets, how you have this mirage effect that happens, sunrise and sunset. That's what it's about. So if you're staying in a coastal area in Japan, sometime between late autumn and early spring, you may have a chance to see this omega-shaped sun at sunrise or sunset. So it's the same thing, it's purely an optical phenomenon. I just don't want to go. There's not much there to read about, but you can read up more about this. It's a pretty well-known thing that happens. But it takes this particular shape at this particular time of year in Japan in the winter time. Okay, here are I'm just going to move on. Here we are, right? Sunset of the habitable worlds. So this is like nonsense, where they're showing what a sunset would look like in these, like there's Earth, and then there's these four different supposed sphere Earth type worlds. Kepler 22b, Gliese 667c, blah blah blah. And this is what it would look like if you were on these planets. It's total nonsense. They have no idea what the sunset is here. Never mind trying to show what a sunset is in somewhere else that they've made up within their model. But that's what they do. Okay, I have this playing, I think, at the right speed. I have it playing at 75 speed. So this is with a solar filter by BLMSB. Shout out to him. This is a sunset with a solar filter. Now, I'm going to leave it play. And as you can see, it's right across the water here. And something very interesting happens. Even with a solar filter, when it gets close to the what we see as the horizon line, it goes down, going down, and it gets to here. And you can see, even with a solar filter, it starts to mutate. It's mutating, and it just disappears. Gone. So I'll just go back and show it again. Even with a solar filter, it mutates. So I go back a bit more. As you can see, it's mutating. And it just gets to a point and gone, right? So I'm just going to get these, right? So here it is. I make this full screen. And as you can see, it's starting to mutate. Let's see if I can go in on it. Here. Look, it's starting to mutate. And again. Oops, going too far over. It's starting to mutate. So even with a solar filter, it starts to mutate. And again. It's mutating. As you can see, it's starting to mutate. So even with a solar filter, it's starting to mutate because it's not a physical, it's not what we're seeing at the horizon, even with a solar filter, is not something physical. We're seeing an optical phenomenon. Let's see if it does that now. So I think that was the last photograph. Yeah, it's the last of them, because the next one is just from that point. I'm just going to show from this point, the next, even on the video, it's just gone, disappears. So that's what you see, and suddenly it disappears. So it's purely optical, right? I don't know if the sun is physical or not. I have a feeling it's not, but I don't know if it is. I don't know what it is, how it does what it does. All I know is that I don't know. That's all I do know. But one thing I do know for definite, one thing I definitely know for definite, Is that, I thought I turned off the video for a second, is that the horizon is not a physical location, and the the sun that we see at the horizon is not physical. So we're seeing two optical phenomenons meeting each other. That's what we're seeing. That's what we're seeing. Two optical phenomenons meeting each other. We would think that's the horizon if we couldn't see it, but right, this is the horizon to us, and it is because it's just an optical phenomenon. But that doesn't mean that that's where the water stops or goes down. That's where the water starts to go down over a curve. No, because there it is out here. Same way with the boats. Where is it? This one, good one. With the boats, is that the horizon? It is to us. But is that the end of where the water? No, the water goes off out here underneath that boat and off again. So we're not seeing any. We don't see any physical sun hitting a physical, going down behind a physical horizon. We see two optical phenomenon meeting each other. That's what we see, and it's even officially termed that way. Then we come up with explanations for what's happening behind the scenes or afterwards or whatever, but it doesn't matter. Officially, the horizon is not a physical location, and the sun at the horizon is just a mirage, and that's what you're seeing, two optical phenomena. So the next time someone wants to ask someone on the flat Earth side, how do you explain a sunrise? Tell them exactly the same as you do, with the exception of we don't add in a load of rubbish with it that we can't support. That's the difference. Thanks for watching.